Um, Hi everyone, I'm Mahram from MahramTech. On this channel, I teach Python and other programming and tech tools topics in a simple and practical way. So, what do what will we do and learn in this episode in Python 2 Basic Part 2? We will learn about projectile motions. We will program with Python this formula. And let me tell you what is this formula. Explain it. Full name is kinematic equation for rotation with constant acceleration, or simply is a equation of vertical motion or of projectile motion. So, if I explain this, it's this formula. Like it comes from Newton's second law of motion. So it has been integrated twice. Like first, it started with the constant acceleration, a equal minus g, the gravitation, and the second, it has been integrated once to the velocity, so v equal v0 minus gravity and time, and so integrated again with the position and displacement. So it's y, which is the vertical, equal to v 0 and time minus 0.5 times gravity and times. So what are those symbols? Y is meaning the vertical position of height, and it's measured in units meter in this one. And I can tell you later why it was taken by default meter. The velocity 0 is the initializing upward velocity in meter per second. And I can also tell you why it's meter per second by default. It's just because of this guy, the acceleration due to gravity. It's by default is 9.81 meter per second per second. And time, it is the since the time has been launched, and that's it's also in second. So so we will let's do this in Python code. This formula for the projectile mission. So first we will create a file called ball as an example, ball.py. So the normal I will use VS Code. I'll just grab my VS Code first for Paris and to find my VS Code. I'll be back. So I found my VS Code. So I shared my screen, and now as you can see, we can see the film on the right side, and then here's my VS Code. In VS Code, first I will need to create a folder. This is just for my own structure. You can also do it in your own way. So I will call it like Python basics, and let's call it E2, and then projectile motion. So here I have folder, and then inside that folder I will create we can again create a file name for ball.py. So here it is, and then so we will do this formula in Python. And so first what we I will make a comment to we make a program for computing the height, also the y of yeah, of a project given time of or of a ball in vertical projectile motion. So vertical motion. So and then next we don't need this. So we have to declare our v. We call it v0 space. We have to give it like the height, the speed, the speed, velocity. So it should be. I will give it like maybe 5. So this is where we initialize, yeah, meter per second. So it's like I did it 5 meters per second, and then we have to declare the gravity. It is a g. It is yeah, it comes like 9.8 acceleration of gravity. I already have it. Meter per second with the gravity, and then we need the time as well. So we give it like 10, let us say like 0.9 time in seconds. So it's a second. And then we need at the end, we have to save it. So at the end, for the height, we need this. Or let me change this to something like 6. And then for the height, what we need is like height equal v. This comes so because is 0, and then times by 10, and then minus 0.5 times gravity times time, and then it. So and in this one here we will print the height of the ball. I do like this. I have automatic, so what we are interested in, so we are printing the height of the ball after time and second has been in meters. So you save it, and then first time. So as you can see, so the height of the ball after 0.2 second is like 1.2, 23 meters. So we just did it. So that's it for the video. Thank you for watching. More about, I will teach more about phase analysis. Thanks. I forgot to tell you this. This h is the height simply as equal as the y that we did on the formula. So I have to correct myself. Came back. So we just do this one, then try and run again. So we see here is the output. So the height, the value after 0.6 second is 1.23 meters. The same as we got earlier. Thanks.